All right, so this gives you an idea of the overall setup of epithelial tissue. We have cells and a basement membrane, and then we are connected to some type of connective tissue beneath. Real quick, these microvilli and cilia we will see on the cell surface of some particular epithelium. Microvilli are for absorption and secretion, and cilia, as you can see, they're a little longer, more finger-like if you will, and these are for movement along the cell surface. Classification of epithelial tissue is going to be by layers or shape. So arrangement of layers, a simple epithelial tissue is going to be a single layer of cells. Stratified is going to be multiple layers of cells. And then in between we have pseudostratified. What this means, it appears to be layered with these nuclei sitting on top of each other, but in actuality each cell is attached to the basement membrane. Therefore, pseudo meaning false, this is going to be falsely stratified. So that is the difference between those three layer types. Cell shape, we have squamous, cuboidal, and columnar. Squamous is going to be flat. Cuboidal is going to be cube-like. Imagine that. And then columnar is going to be column-like. Imagine that. And we're going to look at some different ones here in a little bit. Okay, so we can be arranged in many different ways. We'll see simple squamous, stratified squamous, simple cuboidal, and so on. And this just gives you a good outline and a written version of how to describe these different types of epithelial tissue. Now, when you go to naming or seeing the name of a different tissue, the way they are named is the top layer, whatever shape it happens to be, is how it will be named. So if the top layer is going to be squamous, then no matter how many layers are beneath it, and if the bottom layer happens to be cuboidal, it will still be stratified squamous epithelium, meaning multiple layers of cells with the top layer being flat. Alright, again, another link for your viewing here. This is just showing that squamous cells can be simple or stratified, cuboidal, and columnar also. Pseudostratified will always be columnar. Alright, so simple squamous epithelium. These next few slides are going to show their locations and their functions. So location of simple squamous epithelium, we will see them in those serous membranes we talked about, the pleura, pericardium, and the peritoneal cavities, lining the inside of the heart and blood vessels, and there are a few more examples here. Now the one we'll see more of is going to be the blood vessels. It's a very good example. Very thin layer of epithelium allowing for passage of substances in and out of the capillaries, or those very small blood vessels. This is where we see white blood cells moving in and out, oxygen moving in and out, and so forth. So the functions, we reduce friction. This is the purpose of the serous membranes. We control vessel permeability, again, allowing substances to move in or out. And then we have absorption and secretion. Stratified squamous epithelium, on the other hand, we will find it on the surface of the skin, lining of the mouth, and a few other places. The reason why we find this in especially the surface of the skin, we are providing a physical protection against abrasion. So the more layers we have, the more protection we have against abrasion. So if we brush up against something, we may lose a layer or two of skin in that particular area, but luckily we have very large amount of cells that are able to replace. Simple cuboidal, kind of specialized. We're going to be in glands, some ducts, and portions of the kidney tubules, and then of course thyroid gland. The functions are fairly limited, but we do see secretion and absorption. Stratified cuboidal epithelium, very rare, so lining of some ducts, again protection, secretion, and absorption. Transitional epithelium, this is kind of a neat type of epithelium really. Find it in urinary bladder, renal pelvis, that's in the kidneys, and then the ureters. So this type of epithelium will allow for stretching, but it will also recoil to its original shape in a relaxed state. So if the bladder becomes full, we are able to stretch while being able to return to our relaxed state without any damage. Hence, transitional. Simple columnar epithelium, so a single layer of column-like cells. We have lining of the stomach, intestines, gallbladder. These are very specialized cells as far as what they do in those areas. They do have different purposes, but we see secretion and absorption having a large function in most of these areas, especially lining of the stomach and the intestines. Also, we have a little bit of protection happening here. Now, as you'll see, we have microvilli seen on top of these cells. So microvilli, again, secretion and absorption. Pseudostratified ciliated columnar epithelium. So cilia for movement along the surface of the cell. So lining the nasal cavity, trachea, the bronchi. Then we have a little bit of secretion, but we are moving mucus with that cilia. So in the nasal cavity, we're able to move that mucus posteriorly into our throat, allowing to get rid of any of that overage of mucus production. Alright, and then the glandular epithelium, again, very specialized, very specific purpose as well. We have two different types of glands. We have endocrine and exocrine. So this first slide is looking at endocrine. We are secreting hormones into the interstitial fluid, and those will move into the bloodstream. Next will be exocrine glands. The difference between these, exocrine glands do not secrete hormones, but their substances are secreted through ducts onto the body surface or into a hollow organ. So we are not creating hormones, but secreting different substances. And that's where we will take a break. Next, we will start in on the connective tissue. I lied to you. Look at this right here. So we have classification of glandular epithelium. This is not going to be a big part of the testing, but the merocrine, apocrine, and holocrine are different ways that we secrete this glandular secretions. Merocrine, we create little vesicles within the cells, and those release the substance. Apocrine, we collect those vesicles at the apex of the cell, and then that cell, the top of that cell is pinched off, and it becomes the entire secretion. Holocrine, we collect a large amount of those vesicles within the cell, and then the cell bursts, killing that gland cell, and it is replaced with stem cells. Alright, now we end, and I'll see you for the connective tissue.